Section 4.4, scatter plots. This is actually not the entire lesson or the entire section in the textbook. This is only the first half of the lesson in the textbook, but we're not going to worry about the second half because the second half deals with lines of fit, and it deals with a lot of work by hand and kind of estimating and doing a lot of things that are very tedious and kind of difficult. And with technology the technology that we have at our hands, it's not really important. I don't think. Okay, we can use technology to make things a lot quicker, a lot more efficient, and a lot more accurate. So I'm not going to worry so much about the lines of fit. We're going to focus in this video on scatter plots. So we're going to start with a vocabulary term, and that is scatter plot. Scatter plot is a graph that shows the relationship between two data sets. Now, the two data sets might be related, they might not be. You could have something like hours watching TV versus height, or you could do something like GPA versus shoe size, or anything like that. Or you could do things that maybe do have some sort of relationship, like hours spent studying in GPA. Okay, that would be an example of something that is probably related, and we'll get into that in a little bit. Okay, but just a scatter plot is just a graph that shows the relationship between two sets of data, and we can make statements about that relationship that we see. Okay, so I've got an example here. You might want to pause the video so you can get this thing drawn. I've used a lot of screenshots from Desmos, and that's going to be a big help for you going forward. So just keep that in the back of your mind. Scatter plot shows the amounts of time X in hours that 8 students spend on homework each week and their GPAs, which are the Y values. Okay, so take a minute, pause the video, get this thing copied down, and then we have a couple of questions to answer over this scatter plot. Question number 1, what is the GPA of the student who spends 6 hours a week on homework? Well, what we're going to do is we're going to go find 6 on the x-axis, because 6 represents hours, or I'm sorry, the x-axis represents hours, and that's 6, and we're going to go find that data point on that x value of 6. And then we go all the way over, and we find that we have a GPA of 2.0. That's all there is to it. Question number 2, how many hours a week does the student with a 2.75 GPA spend on homework? So we're going to find 2.75. These are split into 0.25s, 2, 2.25, 2.5, 2.75, and then 3. So we're going to find 2.75, and we're going to follow it all the way over, and we find 12 hours. This person spends 12 hours on homework every week. And then question number 3, what tends to happen to GPA as the number of hours spent on homework increases? Well, we can kind of see a general trend. The more time we spend on homework, the higher the GPA becomes, generally. Okay, we can see that there's some students that spend only 10 hours, and they've got a very strong GPA. We got 16 hours, strong GPA. Or 10 hours to 12 hours is a decrease. Or 6 hours to 8 hours is a decrease. Every person is going to be different, so this is not going to be a perfectly straight line. People don't work that way. But as in general, as we increase the number of hours that we spend on homework, the GPA tends to increase. So this is just going to be increase. That's all there is to it. If we see a relationship between the data, like we saw here in this scatter plot, as one goes up, the other goes up, or as one goes up, the other goes down, something like that. That's called correlation. A correlation is a relationship between data sets. It's not cause and effect. Okay, it's not because I studied for 16 hours, my GPA was 3.75 or 4.0 or whatever it might be. Okay, a correlation, we can just say the hours spent, as we spend more hours doing homework, the GPA tends to go up. We can't say that it's a definitive cause and effect. We'll get into that in section 5. But with correlation, all we can say is there is a relationship, or maybe there isn't. We'll get into that here right now. So there's 3 types of correlation. There's positive correlation, there's negative correlation, and then there's either none or zero correlation, however you want to say it. It doesn't really matter. I'm going to draw you 3 pictures here. Positive correlation. We just had an example of positive correlation. Looks something like this. As the x value, as the x data set, whatever that might be. In the previous example, it was hours spent doing homework. As one gets bigger, the other one gets bigger. So that would be your GPA. As x gets bigger, y gets bigger. Negative correlation kind of looks the other direction. As one gets bigger, the other gets smaller. Notice I'm not making just a straight line. These points, when we're talking with people, generally people are not linear. We're not all robots. We're not all built the same. We don't all do the same things. If I could say I have a size 13 shoe and I'm 6'4", if I could find somebody else with a size 13 shoe, they should be 6'4". But we all know people with big feet that aren't that tall, or we know tall people with not that big of feet. Okay, it's not a one size fits all statement. So none of these pictures are going to be straight lines. Okay, but just keep that in mind. There will be trends in your data. As one goes up, the other goes up. That's positive. As one goes up, the other goes down. That's negative. So this could be something like hours spent watching TV. This could be test scores. As you spend more time watching TV, you're probably not studying, so your test scores are probably going to go down. Then the final correlation would be none or zero, and that's just no relationship at all. There's no way you can say there's a trend there. Okay, this could be something like shoe size versus GPA. There's no relationship there. Okay, it's called positive because if we were to draw a line through this, that would be a positively sloped line. Negative correlation, same thing. If we were to draw a line through that, that's a negatively sloped line. And then no correlation, well, we can't really draw a line. So that's the reason behind the naming of positive and negative correlation, because it's a positively sloped line, negatively sloped line if we were going to draw a line through it. Okay, a couple of examples here and then we're done. Make a scatter plot of the data and describe the correlation. So again, I would potentially pause the video. As soon as I'm done talking here, I'll tell you when to pause. But I would get this table written down, and then we can answer some questions about this. So number one, the X value represents temperature. The Y value represents attendance, and that's in thousands. So this could be, at an outdoor sporting event, an outdoor concert. Could be something like attendance, or maybe attendance might be a poor word, but business at like an ice cream shop like T&L's. As it gets warmer, people might tend to get more ice cream. So take a second, pause the video, and then we'll discuss this one. All right, so here's how we're going to do this. We're going to use Desmos. If you don't have Desmos pulled up, I would highly recommend pulling it up on your computer or on your phone. Desmos has an app for your phone. It works just like the computer version, so it's really handy. There's no new skills to learn. Here are the steps you're going to do, and I'm going to switch the page here. So when you get to Desmos, open up just a new graph, the most basic website you can get to for Desmos. And what you're going to do is you're going to click this plus in the upper left-hand corner. It's going to bring in add item. It's going to give you expression, note, table, folder, image. Obviously, what we're going to want to do is table. Okay, we're going to create the table. What we're going to do is we're going to recreate that table there in number one. Okay, and that's what I've got here in this second picture. I recreated my table in one, or my X values in X1, Y values in Y1. Okay, and then what you can do, so you don't have to worry about trying to find the points, if you click this plus in the upper, or this lower left-hand corner, right below the table, what it's going to do is it's going to zoom, it's going to change your window on your computer, change the graph picture so it looks something like this. It will show you all of the points kind of in a zoomed out version so you can kind of see what exactly is going on. So the question was asking, describe the correlation. So we've got the scatter plot. We used the technology at our fingertips to make the scatter plot. What can we say about this correlation? Is it positive? Is it negative? Or is it zero? Well, I think we can kind of see that, as the temperature goes up, our attendance went up. Now maybe, this was a really hot day and nobody wants to sit out at a ball game when it's 92 degrees. Or maybe it was really hot but it stormed and nobody wants to go sit out in the rain during a concert or a game. So maybe the attendance dropped that day. But in general, as it got warmer, more people came to these events. So I would say for number one, this is definitely an example of positive correlation, for sure. Okay, let's flip back. Number two, again, pause the video here. Whoops, I didn't even give you the website, www.desmos.com/calculator. That will take you right to the calculator, the graph screen there. Pause the video again, get this table written down, and then we'll discuss this one as well. So the X value represents age. Y value is in thousands. Again, this is age of a car. So if we hold on to a car for 8 years, our value is $7,000. 4 years after we buy it, it's $18,000. Okay, you guys can get the picture there. So again, we're going back to this. I'm not going to go through all the steps with you. I don't have pictures of these again because I'm assuming you can get these figured out. I'm just going to bring up the picture. This is the scatter plot of that table, and I think you can hopefully see that this is a pretty obvious negative correlation, because as the longer we own a car, the value goes down. That's a pretty general consensus. Now there are some cars, obviously, that increase in value as time goes on, but maybe when those cars were first purchased, maybe they did something like this, and then eventually they'll turn back up and increase in value. Maybe, we don't know. Based on the information we have, definitely a negative correlation.